Resume. Hello, everyone, and welcome to Clara's next webinar, Getting Started with bhyve, hosted by myself, Alan Jude, the CTO here at Clara, and Jim Salter, one of our OpenZFS mercenary sysadmins.
Hi, everybody.
So in today's webinar, we're going to go through an overview of some of the concepts and terms that we're going to be talking about, talk about some of the tools you can use with bhyve, then get into the basics of actually configuring some VMs, and then answer your questions. So take it away, Jim.
All right, so before we get started, real quick 10,000 feet overview of virtualization. I think hopefully we all know the difference between VMs and containers or jails at this point. It mostly revolves around the kernel. If you're running a jail or a container, you're sharing a kernel with the host operating system, whereas a VM is a truly fully encapsulated operating system running beneath the host. In Pinocchio terms, it thinks it's a real boy. So the other thing that can be confusing if you're just getting started with this stuff is you'll see a lot of different synonyms for the same thing thrown around. In particular, you see some people talk about hosts and guests. Guest is just a fancy word for virtual machine. It means literally the same thing, so don't let it confuse you. The host operating system is what's running on the bare metal, and it can have multiple guest operating systems, and those are your virtual machines. The other thing that gets tossed around a lot in academic discussions, and frankly, I think the distinction is a little overrated at this point. You'll see folks talk about type 1 hypervisors versus type 2. Those are usually grouped in as bare metal versus software hypervisors, but that's not really the best description. This made a lot more sense in the days when your choices were something like Zen or VirtualBox, and your truly software type 2 hypervisors were much, much slower because they weren't using onboard CPU features to run your guests literally at a bare metal performance level. But these days, pretty much everything decent out there is using CPU hardware features and runs at near native performance. So the remaining distinction between type 1 and type 2 kind of boils down to how fat the host operating system is. People like to say that there really isn't a host operating system with a type 1 hypervisor, but I think that's a little precious. It's certainly limited. The idea with type 1 is that you do absolutely nothing on the host to the extent that you can, and everything happens at the guest level. Whereas with the type 2 hypervisor, you have a full host operating system, and you can ask the host to do complex tasks on its own, not only inside the VMs themselves. But everything these days, in my opinion, is kind of a mix between type 1 and type 2. I feel like that's more of a slider bar than a toggle.
Yeah, like I would say now the definition has kind of changed to a type 1 is basically if all you do is run VMs on the host, and then a type 2 is, if it's this computer does other stuff and runs VMs, but that doesn't really fit the original nomenclature, but it's basically what we have now.
Yeah. So the next thing that that's good to understand going up front is how you handle hardware in your guests. Basically, one way or another, because your guest, remember in Pinocchio terms, it thinks it's a real boy. So it's got to have device drivers. It's got to have a set of, hardware devices, quote unquote, that it can access, and it treats them as though they were real. There's two basic ways to do this. The first is with emulated virtual hardware, and that's where you take a very well understood, long supported piece of actual hardware, for example, an Intel E1000E gigabit network card, and you emulate that. So in the guest operating system now, you just tell it, hey, you've got an E1000 NIC. It uses its built-in E1000 driver. It interfaces seamlessly with the virtual network adapter, and everything just works. So this is nice because you don't need any additional support built into the guest operating system. In a lot of cases, you can run an operating system as a guest, even when it was never designed with any idea of being virtualized, because again, it just thinks it's on real hardware. But there are some drawbacks to that model as well. When you're emulating real hardware in Virt, you have to emulate all the things that hardware does, and a lot of them just don't really make sense for a virtual only device. You end up having to handle a lot of interrupts that you wouldn't necessarily, which can reduce your overall performance. You also have a possibility of introducing bugs because you've got needlessly complex fake hardware that has to be that complex because it has to interact with a full device driver designed around that hardware. So the next approach is para-virtual hardware. Now, the most common example of this that you'll see is VirtIO drivers. Those are very common in Linux KVM. bhyve also supports VirtIO hardware, which I love that it supports the same para-virtual hardware. Now, by contrast, the VirtIO network card, VirtIO Net, it's not pretending to be a real network card. It's its own thing. It needs its own driver. But because it doesn't have to do anything that it isn't, you can make that driver a whole lot simpler. You don't have to deal with, additional interrupts that are based around the idea of dealing with real world hardware that isn't really happening at your level. You usually will have higher performance with para-virtual hardware and fewer vulnerabilities.
Yeah, it's less code overall, and it knows it's virtual. So it's just like, here, I'm going to put all these packets here and then tell the host, hey, come get these. And then vice versa for the incoming packets. And it's much simpler.
All right. So when we say hypervisor, if you're not sure what that means, it boils down to the kernel of virtualization. So there's not a whole lot of direct user-facing stuff going on in the hypervisor because really its whole job is just, it's confusing to use the word containerize, but let's just say encapsulate the guest away from the host. So your hypervisor is going to control how the guest's access to the real hardware resources is allocated, how it interacts with it, and it's going to enforce separation between the two. Now, as the actual user or sysadmin of the host, what you're going to be interacting with is not the hypervisor directly so much as the tooling and scaffolding that accesses the hypervisor. So your tooling is going to do things like, this is how you're going to start your VM and stop your VM. It's how you're going to take snapshots of it. It's how you're going to pull a console on it. When you get a graphical console on a guest operating system and you see it pop up in like a VNC window or what have you, that's what you're interacting with there. It's the tooling around managing this stuff. We pretty much covered this already. The host is the bare metal. And the guest is just another word for VM. Hopefully by now we all know what a VM is. Yeah. As usual, I have pre-talked half of my slides in the opening, but you've got kind of this for reference if you want to look at the slide deck later. Again, type 1 is supposed to be bare metal. Type 2 is software or hosted. But in modern terms, you'll very rarely encounter something that's all the way one thing or the other.
Yeah, like even most type 1s now are some generic operating system rather than something specialized, and it just doesn't do very much other than just run the VMs. And the type 2 is a little more like, on my laptop, I do all my web browsing and stuff, and I happen to run a VM. But in most cases, it uses the same software either way. And so the distinction between these two types is pretty much gone away.
All right. So one of the most important things when you're figuring out how you want to do your virtualization is the storage layer. And when we talk about the storage layer on the host, this is basically, where we put the data for the guests. Their virtual hard drives have to be stored somehow, some way. In the earliest days, this was usually just a raw file that was stored on, a simple file system like ext4, or sometimes you do pass through and, pass an actual physical hard drive directly down to a guest. That's not usually what people are doing these days, and it's certainly not what we'll recommend here. When you're working with bhyve, nice thing here is that if you're working with bhyve, you're almost certainly going to be on FreeBSD, which means you've got built-in OpenZFS, which I would say is pretty much the ideal use case for the host storage layer for your guests, because you can put each of your guests into its own data set. That means that you can tune that data set for performance individually in ways that doesn't impact the others. So if you've got a guest that's doing, for example, MySQL database engine, NODB, well, that uses 16K page size. So you can set the record size for 16K to that specific VM, or better yet, to a single virtual drive associated with that VM. So maybe you've got a higher record size on its C drive, but you've got or I say C drive, well, it could be Windows and MySQL. But the point is the root file system for the guest could have a higher record size, and you might have a dedicated drive for that guest that's just for your MySQL database, and it has the ideal tuning for that. It's really nice.
Yeah, and that really complements the inline compression, right? If you can use a larger record size, you get more compression, but in a database, there's too much, read, modify, write for that. And so you want to keep the record size on the disk that's hosting the database small, but allows you to optimize each different virtual device, whatever way makes most sense for that, and per drive in a VM, but also per VM.
Absolutely. So, one example of where this might come in handy is, let's say that you want to build a highly trafficked web-based database application that lets you do things with images, photo management, what have you. You can set up one data set for the actual MySQL database that manages all the metadata for your images, and have it with a 16K record size, which is optimal for MySQL. You can have in the same VM or as a separate VM, in your overall web stack where you do your photo storage. Over there, you want the 1 meg record size because you're dealing entirely in large image files that you don't need to do random access inside. So you can really get your performance to where it needs to be with everything without a whole lot of sacrifices. And the next thing is, because we're using OpenZFS, we get built-in high-performance snapshots. So you can instantly take a snapshot of your VMs on an individual level, even individual drives within the VM, what have you. And you can maintain multiple points in time that you can either cherry pick data from later if you have a problem, or roll the entire VM back to that point in time. And the snapshots get taken instantly. They can be rolled back to instantly. And it's not uncommon, like for me personally, to have about 60 to 100 snapshots per VM just automatically taken, not even counting anything I might decide to manually take because I'm about to do something that might be a little risky.
Right. Plus, you get the option of clones. It's like, I have this VM, it's set up just right. I want a second one that's different, and you can just clone it and make a couple changes. Now you have a second VM.
There are some downsides to cloning for the second VM, because you can't really get rid of that dependency. You've permanently linked those two separate images when you make the clone. The clone is linked to a snapshot. You can't delete the snapshot, and eventually they diverge. Where I really like using cloning is when you want to do some R&D. You want to start out with your production stack, but you want to test some things, you want to change some things around. Well, you can just clone production. You can mess around with it, change settings, do whatever, run that clone on a private network, figure out what you needed to figure out without any risk of damaging production. Then you can make those changes that you made in production, destroy the clone, and move on with your day. It's a really nice way to work. Yeah.
Or even just, you're about to upgrade one of the applications that involves, updating the database schema, and it's going to change a lot of stuff. Being able to try that first and make sure it's going to go smoothly is really nice. And then you always have the snapshot to be able to roll back, but with the clone, you can do it off to the side where all that maintenance doesn't require downtime on your website.
Yep. So next thing, extreme corruption resistance. Most of the folks who know to find a webinar from Clara at this point are probably well aware. ZFS does, per block strong, I shouldn't say strong, cryptographically they're not strong, but checksums that, and actually checksum's not a great word either. Really, it's a cryptographic hash. And if the contents of your block don't match the hash, instantly when you read it that you've got some corruption going on, and you can repair that from redundancy or parity, as the case may be, which is very nice for keeping unexpected things from happening to data. Inline compression, which Alan already referred to. Compression is great to put on a lot of things like, well, again, MySQL binaries. Typically, a lot of your data is going to be plain text, and it compresses down quite well, even with the smaller record size. And finally, replication. Replication makes a lot of things with VMs possible that you really, really want and just can't get done very well without it. You can use ZFS replication on a running VM with very little, effectively, typically, no significant storage load or compute load to slow down the VM. You never even know what's happening while it's going on, but the replication is snapshot based. So you snapshot the VM and you begin replicating that snapshot. Now, the next time you replicate, you do a differential between the two snapshots. But the thing is, unlike old school differential or incremental backups, there's never this issue of like, well, when I want to restore, I've got to start with a full and then patch it over and over and over again with all these diffs. You've got the full thing on both sides all the time. It happens really rapidly. You can do it on running systems. It's fantastic. Now, obviously, if you haven't keyed your VM first, the effect is going to be similar to if you yanked the power cord on the system. It's basically going to be crash consistent. Now, the good news is if your applications and your servers are not already crash consistent by way of journaling file systems and journaling database storage engines and transactional support in your database applications, that was already a bug you needed to fix. So get fixing.
Yeah, and with the asynchronous replication, it makes it very easy to keep a backup of that VM staged in on another host or in another building or something, to be able to spin that VM back up with only, a couple of seconds or minutes of missing data and get your VM back up in the event of a disaster.
Yep, and because we're specifically talking about VMs, we should point out also that you can boot that replicated VM, where you've replicated it to another system. If need be, you can boot the VM directly on that system without modification. If it's on the same network as the original VM was on a separate host, users never even know that it moved from one to the other.
Yeah, if you configure it with the same MAC address and so on, it's going to come up, take the IP address, and nobody will be able to tell that you migrated it.
Well, presumably, as a smart system administrator, you weren't just replicating the VM storage, you were also replicating its config, which means, yes, it's absolutely going to fire up the same MAC address, same everything.
Yeah, although, you could change it if you wanted to do it differently on purpose, but that's kind of out of scope.
All right. So now let's talk about those guest management tools, the stuff that you actually interact with. One of the issues that I had getting started with bhyve is that there are a lot of tools out there right now, and they don't all entirely work. Like, they're not all finished yet. That doesn't mean that you can't use bhyve very productively and very well, but it helps to know which tools to use to start out with. Now, Alan is mostly doing bhyve via direct command line invocation using the bhyve command itself. If you've got any experience with Linux virtualization and KVM, if you've ever started a VM with nothing but like a 3-paragraph long versh command, that's basically what using the bhyve command is like. Everything generally is going to happen right as arguments on the command line when you invoke the VM. It's primitive, it's really verbose, but it's also quite simple and direct. There's not a whole lot in the way of abstraction layers to have a bug in, so it is convenient that way. Basically, you save your command, and that's all of the information you need about your VM to begin with. Any comments on that, Alan, since you're actually doing that and I'm not?
Not especially. It's, you are spelling out all the devices that are attached to the VM, and it's kind of easy to see what's happening. It looks a little complicated at first, but there's a good man page, but it's probably not for everyone. And, if you are doing a lot of like one-off VMs, sometimes it can be useful, or, I'm using it for doing development. So I'm, booting different kernels and stuff and need to make changes all the time. So it's easy to have that as a command line. But, even for more long-lived VMs and so on, I generally use something like VM bhyve.
So the next thing is what I was really hoping to use when I got started with bhyve. There's a lot of work in getting libvirt, which is the tooling around Linux kernel virtual machines. Libvirt and Virt Manager working. This is really promising, but it's not ready for prime time yet. You can set up VMs using libvirt, and Virt Manager can interact with it. Really interesting, you can also interact with Virt Manager running on a FreeBSD system in bhyve from a Linux machine that's got Virt Manager running on it. And as far as that goes, it all works, and it's a really nice preview for the future, but it's not ready for prime time yet. At this point, if it's possible to actually boot a VM using libvirt, it's difficult, and I'm not sure it's entirely possible yet. Basically, the internet is full of folks saying on forums it can't be done, and I took a good hearty stab at it, but as far as I can tell, those comments are all still correct, and you can't really get the VM booted and running yet. So that brings, I'm sorry, Alan, do you have something? Okay, so that brings us to what we're actually going to talk about today, which is the VM bhyve package. This is ready to use right now. It worked flawlessly in my testing. The documentation can still use a little bit of work, but using VM bhyve it's very similar to using libvirt with Virt Manager. Again, for those of you who are familiar with KVM on Linux, when you look in etc libvirt QEMU, you see a single XML file for each one of your VMs that defines its hardware and how you want it to run and whether you want it to auto start or not. And that's basically what VM bhyve gives you. It's template based, so you can start a new VM based on a template that gives you a generic set of hardware instructions on how to boot it, what the architecture looks like, all that kind of thing. You can start from a known good condition, and then you can just make a couple of modifications to point it to the right storage for the VM, any changes in hardware you want to make, and start it that way. So VM bhyve is, it's still command line based. It's not as nice as using something like Virt Manager because it doesn't, for example, have, just a built-in click a button and, spawn a graphical console on your VM, but you can get everything done that you need to. You've got your single config file that defines all the hardware for a bhyve virtual machine. You can start it with just VM start and the name of the VM. You can VM list, see all of your VMs, which one of them are exposing VNC listeners, and you use your own VNC viewer to connect to any of those listeners running on their various ports to pull a graphical console. I think I'm running ahead of myself, and I've got a slide that's going to tell you this again later. Here we go again. We've already covered this, but for anybody who came in late, emulated versus native or para-virtual hardware. Basically, the emulated stuff is convenient. It helps you support guest operating systems that have no idea that they're virtualized at all, let alone anything about your particular hypervisor. But the para-virtual hardware, it's a little less convenient in that you do have to have a special driver for that hardware. And if that's not built into your guest operating system, that's an issue you're going to have to deal with. But it dispenses with unnecessary system calls and features. Usually the para-virtual hardware is going to be higher performance, but that's not always the case. With bhyve in particular, I discovered that although bhyve does support VirtIO block, storage, the emulated NVMe storage stack on bhyve actually outperforms it significantly for the moment.
Yeah, so I say one of the main times you use the emulated hardware is if you're supporting an older OS that isn't going to have VirtIO drivers, or even just, Windows doesn't have VirtIO built in by default and you have to slipstream the drivers or install them after and so on. So sometimes it's easier to start with the emulated hardware because it'll just work out of the box. But usually if it's available, the VirtIO hardware, the para-virt hardware will be higher performing. Although, like you said, with NVMe, that whole protocol stack is different and is designed for much higher performance. And I think it's why it's beating out the VirtIO block.
Now, I do want to push back a little bit on what you're saying about the Windows install. Yes, Windows does not currently come with built-in VirtIO drivers, and you do need to install them. If the word slipstream gave you hives and it sounded a little too advanced for your taste, though, don't sweat that. You don't need to do that. And I absolutely do not recommend doing what Alan was talking about and starting out with emulated hardware and then changing after the installation to the
no, I wouldn't suggest
stuff.
Changing, because that's Windows and changing drivers does not go well.
Yeah, so for those of you who haven't had to deal with hardware RAID controllers on bare metal Windows installs before, there's a part during the installation where you have the chance to, it tells you press F8 if you want to install extra hardware, or in some versions, there's just a dialog that gives you a button that you can click to install drivers during the installation process. So what you're going to want to do with Windows stuff where you're using, for example, a VirtIO NIC, you can just boot with the ISO, the virtual CD-ROM for your VirtIO drivers in an additional drive, or you can even swap that out, with the emulated Windows installer ISO during the process. And it's very easy to just pick the driver and install it while you're running. You don't actually have to build a slipstreamed ISO with the drivers already in it. That's definitely not necessary. It's convenient if you do a ton of these things, but you do not have to do that. Okay. Again, usually you're talking about performance with the VirtIO hardware and stability for the emulated stuff, but it can go either way, honestly. I've seen for a long time, the VirtIO network drivers for Windows weren't all that stable. And so I was using the emulated E1000 drivers because otherwise I would end up with the NIC locking up and I'd have to reboot the guest, every couple of weeks. Now that hasn't been the case for a couple of years now. I have not seen a significant issue with VirtIO network drivers in, like I said, years now. But that is something to keep in mind. Sometimes you'll have a stability preference or a hardware preference, and you don't always know without experimentation which one you're going to get the best results with. Again, bhyve kind of turns usual expectations on their head. I normally expect VirtIO to vastly outperform emulated hardware, but with bhyve, the NVMe storage stack, which is emulated, it looks just like normal NVMe to the guest. If you install Windows, for example, with NVMe emulated storage, you don't need a special driver for that. Windows just works with it, just like it would with the NVMe chipset on a laptop or what have you. And that is currently your best performing option by far under bhyve.
Yeah, the NVMe has more queues and can do more work at once and do it not necessarily in the same order, which makes it a lot more performant. For the same reason that NVMe is more performant on real hardware.
Okay. Now what we're going to do here is we're going to take an overview of what a VM bhyve config file looks like. This is basically enough arguments to get you a running VM bhyve machine. Now, normally my actual config files, I load them up with comments. Like everything's going to have, a comment leading with a pound sign above the line to kind of let you know what it does. But in the interest of being able to fit everything on a slide, we've got just the meat here. So we start out telling it what kind of loader we want. We specified UEFI. So UEFI, that's the replacement for BIOS, basically. And when you specify a UEFI loader, that helps you, for lack of better words, we go back to the Pinocchio thing again. When you've got a guest that's using the UEFI loader, it thinks it's a real boy. It looks like it's booting up on real hardware. Now that also allows you to specify graphics equals yes. That's the toggle that will tell bhyve that it needs to expose a VNC listener to let you pull a graphical console on that guest. XHCI mouse equals yes is going to be necessary to get mouse tracking to work right inside that VNC listener. Now the next thing, this was something that I found really lacking in the available documentation. Obviously, CPU equals 2 gives you 2 CPU threads, right? But by default, every single CPU thread is going to show up as a separate CPU in a socket. And neither Linux nor FreeBSD guests really care about this much, but Windows will absolutely lose its crap about this because there are licensing related issues with various versions of Windows. And if you accidentally build yourself a 16 CPU machine that looks like it's got 16 sockets, you would need Windows Server Data Center Edition to run that. So to get around that, the additional arguments we use here are CPU sockets equals 1 and CPU cores equal 2. So that means our 2 virtual CPU guest is going to look like it's got a single CPU with 2 threads, which is what you're going to want here. Memory equals 4 gigs. That's pretty self-explanatory. And we get down to the network type. Our type here is VirtIO net, which is generally what you're going to want with pretty much everything. As long as your guest actually supports VirtIO, that's definitely what you're going to want. It will outperform any of the emulated stuff. The next line, network 0 switch, what that refers to is on the host level, there's a network switch that has to be built in for the VMs to tie into to get their own IP addresses and interact with the production network. In this case, public is the name of that switch that we've created on the host. Now we move on to the first disk. The type is NVMe, and the name is disk0.image. Now notice that's not a full path to disk0.image. Unless you specify some additional arguments, that path is going to be relative to the root directory for the VM's configs themselves, as is the VM storage. That can be inconvenient in some cases, like for example, if you want to attach a virtual CD-ROM drive, which is what we do in the next stanza. We got disk1 type is ACI CD. Now the next thing, disk1 dev equals custom. What that argument means is now when we specify the name, it won't be relative. It will be an absolute path all the way to your ISO. This comes in really handy when you've got a library of ISO files including operating system installers, VirtIO drivers, that kind of thing. So by specifying this going dev equals custom, we can point our VM's virtual CD-ROM directly to that ISO where it's in that library at the host level, not segregated down inside the VM itself.
Yeah, like in general, having the images be relative to the VM's directory is handy, especially if you're going to, reuse this template multiple times. Means different version of the VM is going to have the same file name, but in a different directory. But like Jim said, for the ISO, it can be handy to have, one central repository of ISOs and reference that from everywhere.
Now, Alan, one thing I could not find how to do, I probably should have asked you this before the webinar. Do you know of any way to hot swap those ISOs while the VM is running? I couldn't find one.
That is a feature that's under construction. I think it's almost done now, where basically there will be a socket that you can write commands to tell bhyve to change something like that while it's running.
Okay.
But that's not in FreeBSD 13.1 at the moment.
All righty. So when you want to pull a console on your guest, the UFI guests, like we said before, as long as you also specified graphics equal yes, they'll expose a graphical console on VNC listeners. And this is built in and automatic. And when you use the VM list command, as you see here, I did actually pull one of the columns out of the command so that it would show up on the slide and be visible. You get all the information there and one further column, which I believe is the path to the data store for it. But you'll notice here that under the column VNC, we see 0.0.0:5900. That means that our VM has exposed a VNC listener on port 5900. The fact that it says 0000 instead of 127.0.0.1 means that unless you firewalled it away, you will be able to reach that VNC listener from any machine that can reach the host. So that's something to be aware of. In order to actually connect to that console, you will need to install a VNC viewer. I typically use Tiger VNC, basically because that's what I could find quickly in the package repositories, and just VNC viewer. Now, I specified the host and the port there on the command line. You can also just type in VNC viewer and hit enter, and it will pop up a dialog where you can specify that you want to connect to localhost in 5900. And when you do that, you're VNC'd right into your guest. It's no different than if it was another bare metal machine on your network and you were VNCing to it. Now, this console is the difference, actually, though, between running a VNC listener inside the guest and running one at the bhyve level here, is that when you're connected to the VNC viewer that bhyve exposes, you can actually watch the guest boot. You don't have to wait for it to be fully booted and ready and start its own VNC listener in order for you to connect to it. And that's going to be important for operating system installs. It's also important for, a lot of sysadmin level type troubleshooting where you don't want to just be sitting there twiddling your thumbs, hoping the boot process is going well.
Yep.
Now, for those of you who want to do things a little bit more old school, maybe expose a little bit less attack surface, if you do not turn on graphics equals yes, bhyve will not expose a VNC listener. And assuming your guest operating system supports this, you can connect with a, well, actually, the guest doesn't need to support that directly, I don't believe. Does it, Alan?
So with the serial console, you'll get the stuff during boot, but if the guest isn't set up to expose the console on serial, once the OS is running, it won't print anything else to the serial console.
Right. And so anyway, if you want to connect that way, VM console will pull up just a text window. It's like SSHing into something. Thankfully, bhyve's VM console serial connection is not, it's kind of its own thing. So as far as I could tell, it's not locked down to old school like baud rates. So you're not going to be just watching text paint itself on your screen, like what happens when you connect over a real serial console in a lot of cases.
Yeah, it's emulating physical serial, but with, it's definitely, it's not 9600 baud craziness or anything.
And you don't have to set that, which is very nice. Even with emulated serial consoles, frequently you have to go into a separate terminal emulator and manually manage your bit rate and your parity and like all this old school dial-up modem garbage. And if you get any of it wrong, it doesn't work right. It's hitchy, it's glitchy. This is none of that. If you type in VM console and get into a Linux or BSD virtual machine that supports that, it's flawless. It looks like being SSH'd in on the local network. There's no issues with it.
So questions. I think the first question we have is from Trenton, and he asks, can you convert between a Virtual block ZVol and an NVMe storage disk image? Is it just a matter of using DD or some other tool? And will it work with the Windows 10 VM?
So you typically, there isn't really any conversion. You just tell your VM that that's NVMe storage type versus VirtIO storage type. Now, whether it actually boots or not, that's kind of down to Windows itself, and there's not really a hard and fast answer on that. When I installed Windows virtual machines using the VirtIO stack, and then later just changed the storage line in the VM bhyve configs to NVMe instead of VirtIO-block, my Windows 10, actually, I'm sorry, it wasn't Windows 10, it was Windows Server 2019. That VM did boot perfectly happily as NVMe after I had installed it on VirtIO. I don't know whether or not the other would be the case. I'm more familiar with Linux kernel virtual machines, and I can tell you over on that side of the pond, sometimes it works, sometimes it doesn't, which is why we said before, like, if you want to go VirtIO, you definitely want to do that driver install, during the operating system installation rather than trying to convert after the fact, because Windows is finicky. Yep. Now, moving past Windows and talking about, BSD or Linux VMs, yeah, they don't care. You can change their storage stack type, prior to starting the VM, and it will just work fine, at the very least for the root file system. Now, if you've got multiple drives, your device name may change if you go from VirtIO to NVMe or vice versa, and that may break your mount points in, etc fstab. So you may have to fix it there, which may lead to you thinking of it as fstab rather than fstab, but it's really not that big of a deal. You just may have, a couple of minor things to work through.
Yeah, so in general, there's not actually a conversion that will matter there. It's just you're exposing the ZVol to the VM, and then it's how you present it in the VM is either VirtIO block or NVMe. And so you can just change that by restarting the VM with a different config. It'll just be up to the host or the guest OS whether it's okay with the device name and type changing, but usually it works, or it's just changing a couple lines in the fstab or whatever to deal with the fact that it's dev nvd 0 instead of dev vtblk 0.
Now, Alan, we've got a couple of questions in the regular chat as well. Our first was from Brandon. How close to a type 1 hypervisor can FreeBSD be? Is there a pre-configured operating system option built on top of NanoBSD or similar to accomplish this?
I don't know that there's a pre-built one, but you could strip FreeBSD down pretty easily. Also, because nothing else is really running by default in FreeBSD after an install, it is pretty much a type 1. If you don't run any other apps on it other than maybe SSH, then it pretty much is a type 1 at that point. You have the option to run other stuff, but if you don't, it's kind of like Proxmox is kind of in the same boat, right? Like if you just use it as a virtualization appliance, then it's kind of type 1, even though the hypervisor is capable of being a type 2 as well.
Well, I would say that FreeBSD is in a better situation for that than Proxmox is, because Proxmox is also going to build in a really fat web interface that there's a lot of potential attack surface on. Whereas a vanilla FreeBSD install, until you install new things on it, it's pretty damn close to, smooth, shiny, and bulletproof. So the less you install, the closer to true type 1 you will be.
Yeah, you're basically the only thing running by default, unless you enable something, is cron tab.
Yeah. All right, before we go back to the proper Q&A, I want to go ahead and clear out Alberto's question as well. And folks, for the rest of you, there is a Q&A button. Please try to stick your questions in there. But in the meantime, Alberto asks, can I run a different architecture from the hosts? And the answer to that is pretty much going to be no. The whole point of hardware virtualization utilizing features on board the CPU is that your architecture is going to match. You're not emulating your system calls to the processor. You're actually running them in a way that is encapsulated and segregated away from the host. But in order to get that level of performance, you really can't change overall architecture. Now, I'm not sure about in bhyve. There are some minor changes that you can make that basically boil down to locking out CPU features that you don't want to expose. Like over on the KVM side,
the Linux kernel virtual machine hypervisor, you may be able to say, for example, I want this to look like an older model of Intel Pentium processor than the one that I have right now, and that will be okay because it can just lock out the newer features. But what you can't do is you can't say, okay, well, I want to run ARM instead of x86 64, because now you're not talking about hardware virtualization, you're talking about full software virtualization. And while that is possible, that's not what bhyve does. That's like what old school VirtualBox does. And if you remember how absolutely horrible that performance was when you used old school VirtualBox, well, that's why.
Yeah. There's work in bhyve to be able to do ARM64 on ARM64, but that's not completely finished yet.
Yeah, and you won't be able to run, just to be clear, you're not going to be able to run x64 on ARM either.
Right.
You've got to stay within the same overall architecture if you want to get that sweet, almost native performance that you can get out of hardware virtualization.
Yeah. So Albert's question about Pixie Boot. I think with the UFI stuff, if you put a UFI Pixie Boot payload in the guest, that yes, you'd be able to do it that way. I've not really tried to do it that way. With FreeBSD's, with one of the other loader options that bhyve has, bhyve-load, it's basically a version of the FreeBSD bootloader compiled for userland, and you can do things like load the kernel directly from the local file system, and then use like NFS root. I do something like that for my development platform where I want to, compile the kernel on my really fast machine, install it to a directory and run that directory as a VM so that I can, iterate really quickly when I'm crashing the kernel working on a driver or something. So I think you can Pixie Boot stuff. I don't have any great examples handy though.
I know that, yeah, I know that it can be done. I have not done it myself, so I can't really speak directly to how easy it is or isn't. It's certainly possible.
So next we have the question from JR. He's asking, have you noticed any significant performance difference between NVMe and VirtIO using mechanical drives on the host? Or is the difference limited to when using SSDs?
I haven't really done much testing with mechanical hard drives in bhyve, but there is such an enormous difference between the VirtIO storage stack and the NVMe storage stack on SSD, even little cheap desktop SSDs. I cannot imagine that there would be no difference because of the way that you can handle multiple queues with NVMe to a degree that you cannot currently with VirtIO, because VirtIO VirtIO predates the NVMe architecture, at least in widespread production. And NVMe itself allows you to queue things a lot more deeply and intelligently. And I would expect that there's going to be some latency issues, even with mechanical hard drive stuff. The best advice I could give you would be try it out for yourself. But yes, I would expect to see some difference, just not maybe as an amazing a difference. And part of the reason that I say that is because I actually haven't done any NVMe testing on bhyve at all when we talk about the hardware. When I'm talking about using the NVMe storage stack, all of my testing has been with SATA SSDs, some enterprise, some really cheap consumer desktop garbage. But in all cases, even though the underlying hardware was not NVMe, the virtual NVMe storage stack was tremendously faster than VirtIO. And it's worth noting also that although bhyve's implementation of VirtIO was not as fast as Linux's in my testing, bhyve NVMe storage was faster than VirtIO with KVM. So there is no world that I've found yet where VirtIO storage stack outperforms bhyve's native NVMe emulation.
Yeah, I think a lot of that comes from, because of the multi-queue and multiple commands at once and so on, it allows the guest to send more to the host. And then on the host, especially when it's ZFS can take those multiple commands and aggregate them better and do the work more smartly. Even if it's only on spinning hard drives, it can aggregate them into larger sequential reads and get more performance out of those drives than if it was only getting, one read at a time and the next one had to wait until the previous one finished.
Yep.
And so the NVMe kind of allowing out of order execution of IO makes ZFS's job a lot easier, and that gives you more performance in the guest. So then we have a question from Enterneg. He's asking, currently they're using bhyve with raw image files, but they'd love to test using some of the other formats out there like OVA, VMDK, QCOW, etc. Or is currently the only thing you can do is convert to raw? I think currently all you can do is convert to raw. There's some work being done to actually be able to read from the other image formats and write back to them. You can use the tools from VirtualBox or QEMU or a bunch of other tools to be able to convert those images to raw pretty easily. And then, if you're writing those to ZFS, it's going to resparsify them and compress them, and you're going to get most of the advantage anyway. So there's not that much of a disadvantage to raw, but it will be nice to be able to just fire up an already made VMDK rather than having to convert it before you can run it in bhyve.
I will say also, if it's an option, I would strongly recommend using QEMU's tool to convert from VMDK to raw rather than trying to use a VMware converter. I've used VMware converter in anger many, many times over the years. And in anger is usually just a term that means you're doing it for real in production. But no, I mean, I got pretty angry at it. In my experience, VMware convert it's a giant pain in the butt. You got to go through a ton of just unnecessary verbiage and BS just to get the job started. And it's very likely to fail halfway through. Whereas if you use the QEMU tools to convert from VMDK to raw, it will just work every single time. I have yet to have any issues with it. As long as the source VMDK was healthy, QEMU convert will work just fine. It's also faster than VMware converter in my experience, and you don't have to go through any paywalls to get to it. Much better experience.
Yeah, and the tool's much easier to install from packages, and it's just there. And I've done VMDK, OVA, and even QCOW2 and so on, all being converted to raw without any issues.
Alexandra asks, how about PowerPC 64, Big Little Endian? Can those be mixed? Alan?
bhyve doesn't do any PowerPC at all. So I don't know, but I don't actually know if PowerPC's hardware virtualization supports, choosing between big and little endian on the extended page tables or nested page tables. But since I don't think either Zen nor bhyve support PowerPC 64 at all, I think the answer is probably not.
Yeah, I would say that the real world answer is if you're still rocking PPC 64 stuff, it's probably time to really look at an upgrade, honestly.
Well, I suppose it could be Power 9, the new stuff, but even then, I don't know that there's a good hypervisor option there.
Yeah.
And lastly, Brandon had a follow-up there. Is there any functionality for moving VMs between hosts in a cluster to balance resources or in the event of a host failure?
So the answer to that is basically going to be, it's certainly possible, but you need to script it yourself. You've got enough tools to do just about anything that you might want to do with the VMs. Now, I said that, but I may have spoken too quickly from a KVM perspective. Alan, bhyve does have a facility to save system state on guests, doesn't it?
So there's a feature that's about testing quality. It's not turned on by default, but there is pause migration support where you can actually save out the state of the VM to a file and then manually move it around. But after that snapshot, the VM is paused until you resume it, unlike something like a live migration where you would snapshot it, copy that over, and then do a diff on it repeatedly until you get caught up.
But there's nothing stopping you from doing that yourself also. You don't have to do your migration all in one swell swoop. Like I do manual live migrations of VMs pretty frequently over on the Linux side. Also without like just a built-in, easy clicky thing, but it's not that hard. You replicate the storage, once, then you do it again, and it should complete the replication the second time in just a couple of seconds. Now you pause your VM, replicate one more time, and unpause it on the other side, and you're good to go. And under the hood, this is the way live migration always works. You're always going to have a couple of seconds of from your VM while it's moving from one system to the next, particularly if you're also migrating the storage.
Yeah, and with any type of live migration scenario like a VMware, they usually rely on the storage being shared between the two hosts, which isn't actually providing you as much HA as you would hope. Whereas with bhyve and ZFS put together, you can actually be replicating all the storage to another machine and either quickly do a reboot migration or, like Jim said, do the pause migration with that snapshot. It's just that snapshot feature, you have to recompile bhyve with that option turned on because it's still experimental.
There we go.
And then lastly, Tony asks, will the recording of this be available? Yes, it'll be up on our website. And then I think probably less than a week. And then eventually it'll go up on YouTube as well. Okay, we're just about out of time, but we can maybe get one more question if people are quick.
Anyone? Mueller?
All right.
Wait. Alberto's
Sure.
got one.
While they work on that, I'll just mention that if you need help with bhyve or diagnosing a problem or performance or anything, do reach out to us. At Clara Systems, we provide commercial support for FreeBSD, ZFS, and bhyve, and we're happy to help you get your virtualization set up and running smoothly.
Alberto wants to know, now Alberto says, if I want a live snapshot, is there a way to also keep a dump of the RAM? That's what we were talking about earlier with saving the system state. System state includes the contents of your RAM and also things like registers of the virtual CPU. And that's what Alan was talking about, that you need to recompile bhyve to enable the support for that.
Yeah, so for the storage, you would do a ZFS snapshot. And then for the RAM of the VM and the CPU state and so on, that would be a bhyve snapshot, which is a feature that's off by default because it's still experimental, but all the code is there in FreeBSD 13.1.
So realistically speaking, if you don't want to go cowboy with it, you're probably looking at, I would guess probably the next major FreeBSD, not major, than like 13.2, I would guess would probably have it.
That'll probably depend on timing, but yeah.
That's speculation, of course. It's not any kind of a guarantee, but with that feature in an experimental state and available if you recompile right now, I wouldn't expect full production support to be that far off.
Yeah, and then, the idea is eventually to get full live migration, but, there's a lot of work between now and there. Okay. Thanks everyone for coming.
Thanks, folks.